What's up guys, welcome back to my channel. Today we are solving 9702 11 MJ11, our first MCQ paper on my channel. Without further ado, let's begin. Welcome back to GCSE Paradox. Starting with question 1. Decimal submultiples and multiples of units are indicated using a prefix to the unit. For example, prefix milli represents this. Which row gives the submultiples or multiples represented by pico, p, and giga? Alright, so it's something you'll have to memorize for pico and giga. So pico is just 10 raised to minus 12, and wait, let me think for giga. We have kilo, we have mega, then we have giga. Correct. So giga is going to be 10 raised to 9, I guess. Yup. So giga is 10 raised to 9. So the first answer is C. Moving on. Which definition is correct and uses only quantities rather than units? Okay. Let's see. So for density, we know that density is mass upon volume. Oh, only quantities rather than units. So this won't be the answer because it's using meter. It should actually have been a volume, correct? So let's move on to the next option. Potential difference is energy per unit current. Wait. Potential difference is EMF, and this EMF is basically energy per unit charge, not current. Because energy is voltage into charge, correct? So option B cannot be the correct answer. Coming to pressure is force per unit area. This can be correct because pressure is force upon area, and this is only using the quantities. And speed is distance traveled per second. No, it should have been distance traveled per unit time. So very well then. A force of 5 Newton pushes a ball due north, and another force of 3 Newton pushes it due east. What is the magnitude of the net force acting on the ball? So we just have to find the resultant, and resultant is going to be something like this. This is 5 Newton. So resultant force is going to be this. It's going to be 5 square plus 3 square, the Pythagorean theorem. So this comes out to be 5.8 Newton. Alright, so answer is C again. Diagram shows a trace of wave on a cathode ray oscilloscope. Vertical horizontal grid lines have a spacing of 1 centimeter. Voltage scaling is 4 volts per centimeter, and time scaling is 5 milliseconds per centimeter. Alright, so the amplitude, which is voltage, and this is the mean position. Alright, what are the amplitude and period of the wave? So this much is approximately 1.5 centimeter, and we know 4 volt. We know from here that 4 volt is 1 centimeter. So 1.5 centimeter is going to represent 1.5 into 4, which is 6 volt. So the only option with 6 volt is C. So we don't have to actually measure the period in milliseconds for time, but still, just for your understanding, I'll do it. You can see that one complete wave is taking about 4 centimeters, correct? From here till here. Sorry. from here till here, 4 centimeter, and um, time scaling is 5 millisecond per centimeter. So 4 centimeter means 20 millisecond. So 20 millisecond is one period, which makes this correct. So answer C, option C is the correct answer. Moving on, the diagram shows an experiment to measure the speed of a small ball falling at constant speed through a clear liquid in glass tube. The okay, so it's falling at constant speed through this much distance. There are two marks on the tube. The top mark is positioned at 1.5 plus minus 1 millimeter on the adjacent rule, and the lower mark at this. Ball passes the top mark at 1.5 plus minus 0.02 seconds and passes the lower mark at this. Okay, so some uncertainties and stuff is given. Constant speed of the ball is calculated by this. So yeah, constant speed, which is just distance upon time, because speed is constant. And if we want to find the fractional uncertainty in this value of speed, we are just going to have to use the fractional uncertainty rule. So delta S upon S equals delta D upon D plus delta T upon T, where delta represents uncertainty. So delta S upon S is this fractional uncertainty that we have to find. Delta D upon first, to calculate delta D upon D, we need to find the values of D. So D is just this distance, which is 385 minus 115. I'm not looking at the units right now because delta D and D both will be in millimeters, and like the units won't matter because they're effectively going to get cancelled in the end. So 385 minus 115 is, it's 270 millimeters, and these are the uncertainties in the distances. Plus minus 1 millimeters. So we'll need to calculate delta D. So since we know that D is 385 minus 115, we'll have to add the uncertainties of 385 and 115. We'll have to add 1 millimeter and 1 millimeter to calculate delta D, because uncertainties for any two or more values which are added or subtracted, the uncertainty is just going to be the sum of their absolute uncertainties, which is 1 millimeter plus 1 millimeter, which is 2 millimeter. So we have delta D, actually this is delta D, we have delta D, and we also have the uncertainty in delta D, which is this 2 millimeter. So delta D upon D is going to be 2 upon 270, plus now we need to find delta T and T. So T is just 2 seconds, this 3.5 minus 1.5, subtracting these values, so T is 2 seconds. Now again I had told you that since we are subtracting these times, 3.5 minus 1.5, to calculate the change in time, we'll add their uncertainties, because we are just adding them or subtracting the original value. So we'll have to add the uncertainties. So 0.02 plus 0.02, which is 0.04. So uncertainty is 0.04. So delta T is 0.04 upon T is 2 seconds. So the final answer is going to be this. Alright, moving on. Graph shows how the acceleration of an object moving in a straight line varies with time. Okay, which graph shows the variation with time of the velocity of the object? So we know that dv dt is acceleration. So gradient of velocity versus time is equal to the acceleration. So let's look at the first graph over here. According to the first graph, if we see the gradient increases till this point, then it starts decreasing again. Correct. So this is actually what this diagram is showing. The acceleration is increasing to this point, and then acceleration starts decreasing. And as you can see, acceleration is 0 only at the end points, from this point and this point, when the gradient of the velocity versus time graph is 0. Correct. So since that's the case, this graph and this graph are just gonna get cancelled out. And over here, if you see, velocity, the gradient of velocity is 0 even at this point in graph B, which means dv dt is, which is acceleration, is 0, but acceleration is not 0 in between, because acceleration has some value at this time. Hence A is the only correct answer. I hope you guys understand this. Alright. Seventh question. A ball is released from rest at time 0. After 1 second, it bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce after 1.5 seconds. Okay, so ball is released from rest at time seconds 0. After 1 second, it bounces inelastically from a horizontal surface. So the ball is dropped, it goes down, touches the surface, takes 1 second to reach the surface, and after 1 second, it bounces inelastically from horizontal surface and rebounds, reaching the top of its first bounce after 1.5 seconds. Okay, so we just have to calculate the total displacement of the ball from its original position. So it goes up and it reaches. We just have to find this displacement. So since we have been given a velocity versus time graph, we can simply use calculus, and we just have to find area under graph to calculate displacement. But remember guys, this part above the x-axis is positive displacement, and this area under graph under the x-axis is negative displacement. Alright, so let's start with the first part. The first part, this part, is just going to be a right angle triangle, which is half into base is 1 into velocity is 10 area, and this is going to be half into this much is 0.5 seconds into -5, because velocity is -5. So we just, so let's say this is A1 and A2. We'll just add A1 and A2, and the answer we get is B, 3.75. A body has a weight of 58.9 Newton when on Earth. On the Moon, the acceleration of free fall is 1.64 meter per second square. What are the weight and the mass of the body when it's on the Moon? Alright. On the Moon, acceleration of free fall is this. So, value of G for Moon is 1.64, and value of G on Earth, as we all know, it is 9.8. The weight on Earth is this. So we know W equals mg. This is what you're doing for the Earth. 58.9 is m into 9.81. So mass equals 6 kilograms. So option A and option C are out. Now we just have to find the weight on moon, which is again mg, which is 6 kg into 1.64, which is 9.84, approximately 9.85. So the correct answer is going to be B. Alright guys, I hope you understand this. This is actually one of the simplest questions in the paper. A body of mass m moving at velocity v collides with a stationary body of the same mass and sticks to it. Which row describes the momentum and kinetic energy of the two bodies after the collision? So, body of mass m collides with a stationary body of the same mass and sticks to it. So, we have this body of mass m which is moving with velocity v, and we have this. So, this is before collision, and velocity is 0 of this. Then they combine to form a mass of 2m, and we just have to find the momentum and kinetic energy of the two bodies after the collision. So well, we know one thing, that momentum before collision is equal to momentum after collision. So before is m into v for this, and after is 2m, let's say it's x. So this is the final momentum and this is the inertial momentum, but as you can see, the final momentum, the momentum after collision was equal to momentum before collision. So since these values are same, we can say that the momentum after the collision is also mv. So answer is not C and not D. Now comes kinetic energy. So we can say that x, which is the final velocity of the combined mass, is velocity v upon 2. So the kinetic energy of this 2m mass is going to be 1/2 m v square. Alright, so this is going to be 1/4 mv square. So answer is A. Again, this was a simple question. A molecule of mass m traveling horizontally with velocity u hits a vertical wall at right angles to its velocity. It then rebounds horizontally with the same speed. What's its change in momentum? Oh, so the direct answer for this is just D, because we have this wall. We have a molecule of mass m traveling. It hits with velocity u, then it's rebounded with the same velocity but in the opposite direction, which is u again. So if you consider the directions, then we have the change in momentum before collision was mu, and after collision and after the collision momentum was minus mu. So the change in momentum is going to be mu minus mu, which is going to be 2mu, and actually it's actually final minus initial, so it's going to be minus mu, so it's minus 2mu. Alright, that's why the answer is going to be D. A cable car of weight W hangs in equilibrium from its cable at point P. Cable has tensions T1 and T2. Which diagram correctly represents the forces acting at point P? So at point P, let's just draw a kind of free body diagram. There is weight W, there is T1, there is T2, and they are all in equilibrium. So we can just check the arrows and compare with this free body diagram. So weight is downwards in every option. Tension one direction is, for T1 the direction is something like this. So it's correct in both of these, so these are wrong because the direction of T1 is wrong, and for T2 the direction is like this, B. So the answer has to be B. Alright, moving on to the next question. Diagram shows four forces applied to a circular object. Which row describes the resultant force and the resultant torque on the object? So as for resultant force, um, the resultant force, well, that's just going to be non-zero, because if you see the forces in the upward and uh, downward direction, which are 30 Newton and 30 Newton, these are balanced, correct? But the forces in the horizontal direction, 20 and 20 Newton, both are pointing towards right. So 20 plus 20, which means 40 Newton. So 40 Newton is the resultant force, which is non-zero. So answer cannot be A or B. It's something from C and D. Then we have the resultant torque. If you see, let's take the clockwise moments first. The clockwise torque, so it's and let's say this is R, the radius. So from the radius 30R, these are just clockwise moments. So we have 30R plus 20R plus 30R, and anti-clockwise moments is just this, is just a torque because of this force, this 20 Newton force, which is 20 into R, because this is also R and this is acting anti-clockwise. It's 20R. So do you think clockwise and anti-clockwise moments are balanced? Of course not. This is equal to 30, 20, 50, 80R. So answer is just going to be D. Non-zero resultant torque and non-zero resultant force. Moving on. A uniform meter rule of mass 100 grams is supported by a pivot at the 40 centimeter mark and a string at the 100 centimeter mark. So first things first, 100 grams means 0.1 kilogram, which is so 0.1 kilogram, which means the weight is going to be 0.98 newtons. And 0.98 newtons will act from the center. So at the 50 centimeter mark, which is exactly halfway between 0 and 100, the weight of this object is considered to act, the center of mass, which is 0.98 newton, and string passes around a frictional spring and carries a mass of 20 grams, which is 0.02 kilograms, which is 0.196 newton. So 0.196 newton is this way, which means even this force, like 0.196 newton is equal to the tension force in the string, which is 0.196 newton. At which mark on the rule must a 50 gram mass be suspended so that the rule balances? Okay, so let's see. If we check the anti-clockwise moments from, let's consider the moments from this pivot. The anti-clockwise are anti-clockwise, so they are 0.16 newton into 60. 60 because we are taking the distance from 40 till this weight, 100 newtons, 100 centimeters, so 60 centimeters. These are this is anti-clockwise, which is 11.76 newton, sorry, newton centimeter, and clockwise, uh, it's going to be 10 because the distance from the pivot till the center of mass 40 to 50 is 10 centimeters into 0.98, which is 9.8 Newton meter. So we can clearly see that to balance, to make sure that the rule balances, this clockwise moment, which is 9.8 Newton meter, needs to be increased. So the force, the extra mass should be kept on the right hand side of the pivot. Otherwise, if we keep on the left hand side of the pivot, let's say over here, the mass would be like this and it would create an anti-clockwise moment with respect to the pivot. Correct? So we'll have to put the 50 gram mass towards the right of the pivot, somewhere over here, so that it will create a clockwise moment along with this center of mass. And so clockwise moment 9.8 Newton meter plus 50 gram mass, so the weight is going to be 0.49 Newton. So plus 0.49 into x, because we don't know, we have to find out this distance x from the pivot, which is equal to 11.76. So if you calculate, yes, if you calculate, you get x as 4 centimeters. So guys, the answer won't be A. Actually, it's 4 centimeters from the pivot. So it's either 4 centimeter here or 4 centimeter here. And remember, I told you that we'll keep the weight towards the right of this pivot. So that's why it's going to be 4 meters after. 4 centimeter towards the right of the pivot, which is at 40 centimeter mark. So 40 plus 4, which is 44 centimeter, somewhere over here. Alright, a steel sphere is dropped vertically onto a horizontal metal plate. The sphere hits the plate with a speed u, leaves it at a speed v, and rebounds vertically to half of its original height. So we have this steel, we have this horizontal metal plate, and steel sphere is dropped vertically from, let's say, height h. It falls down and then bounces up only till height h upon 2, and it leaves it at a speed v and hits okay, so it has the speed. Okay, so at this point, velocity is u, and after uh, after bouncing, some of its momentum is transferred into this plate, and it emerges with velocity v upwards after hitting. So we just have to find this. So we know that it was dropped from height h initially. So displacement is h, final velocity is u, initial velocity is 0, and a is let's say it's 10. So yeah, this is for the first part. Then after the bounce, s is h upon 2, final velocity is 0, initial velocity is v, initial velocity is v, and a is equal to minus 10 now. No, wait, a is just going to be 10 again, s is going to be minus h upon 2 because it's going upwards. So we just have to find the expressions for both of these. So we know that v square equals u square plus 2as, this formula. So for the first part, for this first part, v square equals u square is 0 plus 2 into h into 10. Alright, so we have this first equation, and for the second equation, this second part, v square is equal to u square plus 2 into a into s. So v square is equal to 10h. Alright, and we have u square equals to 20h. So v upon u, the whole square, is equal to, wait just a minute, yeah, so v square upon u square, which is v upon u the whole square, is equal to 10h upon 20h. So v upon u is going to be root of 1 upon 2, which means the answer for 14th is C. This was an interesting question, to be honest, but we just have to use this v square equals u square plus 2as formula for the moment before the bounce and for the journey after the bounce of the ball. That's it. A block of mass 2 kg is released from rest on a slope. It travels 7 meters down the slope and falls a vertical distance of 3 meters. The block experiences frictional force parallel to the slope of 5 Newton. So 5 Newton upward. What is the speed of the block after falling this distance? Alright, so we can either use the forces method, but for forces we'll have to calculate this value theta, which you can calculate by using these distances 7 meters and 3 meters and then using trigonometry, or we can just use the energy theorem. So GPE is converted to kinetic energy plus some work done against friction. So GP is just going to be mgh, where h is the vertical height, so this is going to be h, the vertical height, which is 3. So m into g into h equals the kinetic energies, which is the final kinetic energy. Let's take its velocity, let's take the final velocity as v, so plus half m v square, oh sorry, we have value of m, plus the work done against friction, which is 5 Newton multiplied by 7 meters, because work done against friction is just force against friction into distance, which is 5 Newton into distance is 7 meters. Correct. So yeah, so we have 2 into 10 into 3 equals v square plus 35. V square is so v square is 25, v is 5. So actually I had taken g as 10 over here. If you take g as 9.8, you'll get answer as A, which is close again to velocity v equals 5. A man has a mass of 80 kilograms. He ties himself to one end of a rope which passes over a single fixed pulley. Okay, so we have this pulley. Man has mass of 80 kg. He ties himself to one end of the rope which passes over a single fixed pulley. Alright, so we have this man. Mass is 80 kilogram, means the weight is 800 Newton. He pulls on the other end of the rope to lift himself up at an average speed of 50 centimeters per second. Alright, so he has this rope in his hand and he's pulling this rope downwards to lift himself up at an average speed this. So since this speed is average, which means it's let's assume it's constant, so the man has to pull using a force of 800 Newton. Alright, so speed is 50 centimeters per second, we know power equals work done upon time, which is force into distance upon time, and distance upon time is just speed, which is force into velocity. So power is just going to be force, which is 800 Newton, the force required to lift this force, multiplied by the velocity. So velocity is 50 centimeters per second, which is 50 into 10 raised to minus 2 meters per second. Which is, oh wait, again I took G as 10. So this is actually 80 into 9.81. Which gives the answer as B. Alright guys, moving on. A body traveling with a speed of 10 meters per second has kinetic energy 1500 joules. If the speed of the body is increased to 40 meters per second, what is its new kinetic energy? Alright, so we know that kinetic energy is directly proportional to v square, because kinetic energy is half mv square. So there are two ways to do this question. We can either use proportionality, or maybe you can use the first part of the question to find mass, then use this mass to find kinetic energy in the second part using this velocity, or you can just directly use proportionality. So yep. So kinetic energy upon v square is constant, so 1500 joules upon 10 square is equal to the final kinetic energy upon 40 square, which means final answer is C, 24,000 joules. You can of course do this using mass, but I find this method easier. Which process does not require energy to be supplied? Oh, a theory based question. See, in boiling, we need to give energy to the system. Even in evaporation, the system takes in energy from the surroundings. In freezing, freezing is an exothermic process. So in exothermic, system gives out energy. So C can be the answer. Even for melting, which requires breaking of the lattice, the solid bonds, energy is required. So again, this is not the answer. The answer is going to be C, freezing. 1.5 meter cube of water is mixed with 0.5 meter cube of alcohol. The density of water is this, and the density of alcohol is 800. What is the density of mixture with volume 2 meter cubes? Alright. So 1.5 meter cube of water is mixed with 0.5 meter cube of alcohol. The density of water is this. So we can just find the total mass first. So mass of water is so we know that density is mass upon volume. So mass is density into volume. So density of water is 1000 kilogram per meter cube multiplied by 1.5, and mass of alcohol is 0.5 into 800. Then we can just use this final total volume to find the density of the mixture of both. So density is total mass upon volume upon total volume, which means the total mass is 1000 into 1.5 plus 0.5 into 800. We'll just add both of these, so we'll get 1900 kilograms upon total volume is 2. So we get answer as D. Alright, a simple question again. A long thin metal wire is suspended from a fixed support and hangs freely vertically. Masses are suspended from its lower end. The load on the lower end is increased from 0 and then decreased again back to 0. So from R to T, the load is increased, as you can see it's going up on the force graph. Then from T to V again, the load is decreased back to 0. At this point it's 0 again. So where on the graph would the elastic limit be found? Well, if you see, elastic limit is the point where uh, even when stretched, the, uh, the wire or the spring can still return to its original length. But as you can see, when it's stretched till extension at point T, and when the load is decreased till 0, it does not come back to its original length, which is 0. It does not come back to its original length because it still has an extension, this much extension. Since it has this much extension, even when load is removed, so T is definitely not the elastic limit, and S is the point where F equals K. S is the point till where F equals Kx is valid. So for this straight line graph, this straight line part, F equals Kx is valid. So this is the proportionality limit. Means there might be some point over here where the where the wire acts elastically, but it will still return back to its original point. So it's somewhere between S and T. So let's see the options. Anywhere between point R and S. No, point R is here, which is no. Beyond point S but before point T. Correct. So B is our final answer. 20 is going to be B. So moving on. The Young modulus E can be determined from measurements made when a wire is stretched. Which quantities would be measured in order to determine E? So you know that Young modulus is stress upon strain, and stress is force upon area, and strain is extension upon the original length. So if you use this to if you combine them, so we have force upon area upon so this is stress, and strain is x upon L. This is strain. So F, we have FL upon AX, which this is equal to Young's modulus. So we can just compare. So of course we need the mass of the stretching load, not the mass of the wire, because mass of stretching load, using this we can calculate the weight, which is the force. So in this equation, E equals FL upon AX. We are done with force. Let's see, we do require the original length of the wire, and yeah, we even require the new length of wire to measure the extension. But if you see the for B, the other quantities do not have the original length, so we cannot just measure extension using the new length of the wire. But in option A, there is extension of wire available. So we have so L is done, X is done, and we can use the diameter to calculate area. So option A is the only possible answer. The four graphs represent a progressive wave on a stretched string. Graphs A and B show how displacement D varies with distance x along the string at one instant. Graphs C and D show how the displacement D varies with time t at a particular value of x. Labels. Okay, so we just have to check which graph is correctly labeled. So this is wrong because this is t, which is time period over here, will not be this, because this is x, this is distance. So this should have been lambda on this. This is correct, but if you see, this is not the amplitude. Amplitude is just this. This is again not lambda. This should have been t over here because x-axis is time. So this would actually be the time period. This is correct. This is actually correct. Option D is correct. Time period and amplitude. Alright, so for 20 seconds the answer is D. Which statement about sound waves in air at constant temperature is correct? So amplitude is inversely proportional to velocity. Come to think of it, amplitude is just the maximum distance from the mean position, so I don't see how it's inversely proportional to velocity, so probably not option A. Frequency is inversely proportional to wavelength. Let's see, we have this equation V equals F lambda, so V upon F equals lambda, so correct. So frequency is inversely proportional to lambda. B is correct, so it's not required to see the other options. A source of sound from of constant power P is situated in an open space. Intensity I of sound at distance r from the sound is given by this. How does the amplitude A of the vibrating air molecules vary with distance r from the source? Alright, so this is also a theory based question. So we know that intensity is proportional to A square, so instead of I we can write A square over here. So if you look at this equation, we have A square is proportional to 1 upon r square, which means if you take the root of both sides, you have A is proportional to 1 upon r, which is option A. The basic principle of note production in a horn is to set up a stationary wave in an air column. From the lowest note produced by a horn, a node is formed at the mouthpiece and an antinode is formed at the bell. So we have a node over here and we have an antinode over here. Alright. Frequency of this note is this. What are the frequency of the next two higher notes for this air column? Alright, so let's see. So this is just for my reference. So the lowest node is when we have an antinode, we have a node and then antinode at the end. And if you see, if you complete this wave, oh yeah, and this much is the length of the tube, L. If you see, this part is actually just lambda upon 4, correct? This is just 1/4 of the wave. So we know that lambda upon 4 is L, and we know V equals F lambda, so lambda equals 4L, and frequency is V upon lambda. Sorry, lambda is velocity upon frequency, so we have velocity upon frequency equals 4L. So V upon 4L is equal to frequency, correct? Then the second node will happen when we have another antinode, which means for this much L we'll have this. Alright, yes. Now this much wave is remaining, so we have covered 3/4 of the wave, so 3 upon 4 lambda is now L, and from this part we know that L is V upon 4F. So 3 upon 4 lambda is actually V upon 4F. So uh, let's take V as, you know, maybe 300 just for reference. So V is 300 meter per second. Speed of sound in air, approximately 300. So 3 upon 4 lambda is 300 upon 4 f, or wait, instead of lambda we can just substitute v upon f. Alright, so so 3 upon 4 lambda, which is equal to v upon f into v upon f is now equal to length L, which was initially equal to v upon 4f. Yeah, so we have 3/4 of it now. We have 3 times it, so we'll have 3 times frequency, which means 3 into 75, which is 225 hertz, and by default D becomes our correct answer. We'll again calculate for this for 375. Now for 375, which is the next higher node, we'll have this. Correct, which is one complete wave and plus 1 upon 4. So 1 plus 1 upon 4, which is 5 upon 4 lambda. So we have 5 upon 4 lambda is now equal to L, and L was initially v upon 4f, so L is now equal to 5 upon 4 v over f. So compared to 5 upon 4 v over f from v upon 4f, there's a change of into 5. Correct. It's increasing by 5 times. So even the frequency will increase by 5 times, so 75 into 5, which is 375 hertz. Alright. Which electromagnetic wave phenomenon is needed to explain the spectrum produced when white light falls on a diffraction grating? Okay, so again the theory part. This is again interference. Because this is when we actually so I hope you all guys know that when you have the diffraction grating, light refracts from and light bends from every slit in the grating, and then there is interference pattern. Alright, moving on to 27 question. So we'll just have to for this question, this is actually an interesting question. We have to find the number of images formed as this eye goes from here till here. So we just have to find n in d sine theta equals n lambda. So if we calculate n, we'll get the number of full images formed by constructive interference, not destructive. Alright, so first we need to find d, and d, to calculate d, we can do this. Like we know there are 500 lines per millimeter, which means per 10 raised to minus 3 meters. So d is just d is simply going to be 10 raised to minus 3 divided by 500, because we have to find the how much distance per line we have to find how much distance one line takes. So 10 raised to minus 3 divided by 500, and 10 raised to minus 3 divided by 500 sine theta. Oh, so for theta we just have to calculate the maximum number of images, correct? So we can take theta as 90 degree, because this eye, assuming this eye moves till here, so we just have to find the total number of images. So we can take sine theta as sine 90, which is equal to n times lambda is 600 nanometers, which is 600 into 10 raised to minus 9. So we get n as 3.3. So we know that full images means it has to be whole number, so we can take around 3. So there are 3 above y and 3 below y, correct? We took only sine 90. So there are 3 here, and there's 1 over here. So the total is 1 plus 3 plus 3, which is 7. So answer is D. Alright guys, this was again a good question. Which diagram shows the electric field lines between the plates? Alright, so let's see. This one is wrong, because electric field lines only emanate perpendicularly from the surface. So if you have a surface like this, they're going to emanate like this. So if you see for this part, if we magnify, we have the surface like this and the electric field line emerging like this, which is wrong. It has to emerge perpendicularly from the surface. That's why B is wrong. Similarly, D is wrong. And well, C is also wrong, because the distance between electric field lines are not constant. If this would have been a proper a proper electric field where the plates are perfectly vertical, then this might have been the case, but this will not actually be the case, because if you see, the distance is different. Over here distance is less compared to over here, so the electric field line is going to be weaker, which means electric field lines are going to be far apart in this region, and then they come closer and closer and closer and closer in this region. So that's why the answer is just going to be A. The diagram shows a charged particle as it approaches a pair of charged parallel plates in a vacuum. So this particle is charged, so it will go somewhere like this or like this. So either upwards or downwards, but it would be a projectile motion, because there are no forces in the horizontal direction. There are only forces in the vertical direction, excluding gravity. There would be magnetic force. So horizontal component would have constant velocity. So option A and B are gone. Constant velocity, because there are no forces in the horizontal direction, as I mentioned. No forces means no net resultant force, which means acceleration is going to be 0. Since acceleration is going to be 0, velocity is going to be constant. So it's either C or D. Then for the vertical part, if you see, we have this particle, it will move like this. Let's assume it moves downward. So the vertical component is going to be the same, but the horizontal component will actually increase for the velocity, because there's a force due to the electric field, and because of this electric field there's electric force, which means and if you see, the plates are parallel, so the electric field would be constant, correct? Since the electric field is constant, the electric force will be constant, means there will be constant acceleration, because force is constant. So answer is going to be C, not D, C. Two parallel plates are distant 85 millimeters apart have a potential difference between them of this. What is the force on an electromagnet in the uniform electric field between the plates? Alright, so first we can just find electric field, which is V upon D. And electric field, the value of electric field will stay constant throughout, like in this whole area. So no matter where the electron is kept, here, here, the electric field is going to be the same, which is 12,000 volt upon 25 into 10 raised to minus 3 meters. And we have to find the force. So we know that electric field is equal to F upon Q. So F equals EQ, which is 12,000 upon 25 into 10 raised to minus 3 into the charge on electron. So Q is 1.6 into 10 raised to minus 19. So if you calculate force, you will get so you will get answer as D, which is 7.7 10 raised to minus 14. Alright, moving on. A copper wire of cross-sectional area. This carries a current of 10 amperes. How many electrons pass through given cross-section on the wire? So we know this formula I equals VENA, where N is number of electrons per density. This is electron density, sorry. And we know current is 10 amperes, so 10 equals okay, V into E is charge on one electron, which is this, into the number of electrons N, into the area, which is 2 into 10 raised to minus, from millimeter square to meter square, which is 10 raised to minus 6. Alright guys, I just realized we just have to find the number of electrons that pass through a given cross section area in 1 second to the given cross section area. So we don't have to consider the cross sectional area. So we can just use Q equals IT, where Q is the total charge, so which is equal to NE. N is the number of electrons and E is charge on one electron. So I is 10 ampere into 1 second, because you only have to find for 1 second, is equal to N into 1.6 into 10 raised to minus 19. E is 1.6 into 10 raised to minus 19. So N is 6.3 into 10 raised to 19 electrons. That was actually a direct question. A battery is marked 9 volt. What does that mean? So each coulomb of charge from the battery supplies 9 joule of electrical energy to the whole circuit. Well, that could be the answer. But let's check the other options. Battery supplies 9 joules to an external circuit for each coulomb of charge. Probably no. Potential difference across any component connected to the battery will be 9 volt. Of course not. There'll be 9 volt across the. There'll always be 9 volt across the battery terminals. No, there might be internal resistance. So no, or the battery might just run out of some liquid. The battery. So between A and B. Well, no, actually A would be the correct answer, because the definition of voltage is E upon Q, and it's only for it's actually for the whole circuit, not just an external circuit. So coming to the next question, this graph shows possible current voltage IV relationships for a filament lamp and a semiconductor diode. Which row best specifies the correct IV graphs for the lamp and the diode? So in case of semiconductor diode, we know that they only start conducting after the threshold voltage is passed. So this seems to be a correct graph, because as you can see, even when voltage is increased till a value, let's say V1, current is still 0, correct, for this part. So V1 is the threshold voltage, and this is the only graph which shows the presence of a threshold voltage. So R has to be for semiconductor diode, so B and D are out. And if you if you check your textbook, this is actually a part you'll have to memorize. For the filament lamp, this is the relation between I and V, P. So 33 is going to be A. The resistance of a metal cube is measured by placing it between two parallel plates as shown. Cube has volume V and is made of material with resistivity P. Connections of the cube have negligible resistance. Which expression gives the electrical resistance of the metal cube between X and Y? So we know that, let's say the side of the cube is L, so V is equal to L cube, and we know the resistance is rho L upon A. So this is going to be rho into L upon A is going to be the area, which is L square. So we get rho upon L, which means it's actually which means V raised to the cube root of V, which is V raised to 1 upon 3, is L. So this is V upon V raised to 1 upon 3, which is option C. Again, a simple question. Diagram shows part of a current carrying circuit. The ammeter has negligible internal resistance. What is the reading on the ammeter? So you know that the current gets divided, and let's first calculate the total voltage. So first we'll need to find the total resistance of these resistors which are connected in parallel. So 1 upon R effective, which is the total resistance, is 1 upon R1 plus 1 upon R2 plus 1 upon R3, where this is R1, R2 and R3. So R effective is equal to 10 upon 17 ohms. This is the total resistance, and current is 5 ampere. So V equals IR, which is 5 into 10 upon 17, which is 50 upon 17 volts. So we know that each resistor will get 50 upon 17 volts. So let's just focus on this part. So 50 upon 17 volts is V, and R is 2 ohms. So current is equal to V upon R, which is 1.5 ampere. So answer is C. So again, if you know the concepts, that voltage would be the same across each resistor, but current would be divided into I1, I2 and I3. So the voltage is what we calculated using the total effective resistance. So yeah, 4 resistors of equal value are connected as shown. How will the power to the resistors change when resistor W is removed? So if the resistors W is removed, let's assume all these resistors to have a resistance of R. So if this resistance is removed, the resistance to this W and X setup, this part will now have a higher resistance, because initially the total resistance was R upon 2 because they were in parallel, but now the total resistance is just R due to X in the absence of W, which means the total resistance of the circuit will increase. So resistance will increase, current will actually decrease in the total circuit, correct? Since current will decrease, and current which gets divided here, so I1 plus I2, even this will decrease, correct? Because the total which they are getting I will also decrease. So it's it's kind of self-explanatory that the current in y and z will decrease, so the power will decrease because power is I square over r, I square r. So both of these will now have less powers, and over here even this was getting divided current, but since W is not here anymore, uh, I suppose that this will actually be short circuited because this is a straight line. So all the current uh, so okay, sorry, this whole branch is removed. So this I this resistance X, resistor X will not actually get divided current. It will get the whole current from the supply, even though it's less than before, less than the total current before. It's still more for X, more than it previously had when W was present and the current used to get divided into I1 plus I2. So X will now getting I, which is more. That's why answer is going to be C. We can even do it mathematically. So now so initially power is I square R, so power and R was getting I upon 2 because the resistance values are equal, so both will get divided into I upon 2 and I upon 2 from I. So power of X is I square upon 2 R, which is I square R upon 4, which means 1/4 of the whole power. But now we don't have this branch, so and the total resistance of the circuit, let's say this voltage is V, the total resistance of the circuit would be R plus R upon 2, which is I guess 3 upon 2R. Yes, 3R upon 2 or 3 upon 2R. So the total current is, initially the total current was V upon R. Now it's I equals V upon 3R upon 2, which is 2 upon 3 V upon R. So total current has decreased by 2 upon 3. Correct. So the final current is in the whole circuit is 2 upon 3 times I, and now X will get this whole current. Its X resistance will still be R, so Px final would be 2 upon 3 I the whole square R upon 4, which is no, not upon 4 actually, just I square R. So it's going to be 4 I square R upon 9. Now which do you think is greater, I square R upon 4 or 4 I square upon 9? Of course 4 I square upon 9 if you calculate decimal. This is 0.25 and this is 0.44 I square R. So power to X will increase. Alright. So moving on. In circuit shown, X, Y is the length L of uniform resistance via R1, R2, and R1 resistors. J is a sliding point, the contact that joins the junctions are okay. Determine the ratio V1, V2. So V1, V2 across resistors R1 and R2. Point is found on X, Y at which the lamp is off. The point at is at a distance of X from X. Alright, so we just have to find this ratio V1, V2. Well, V1 upon V2 is just going to be this distance upon this distance. So this distance is going to be L minus X and this is well X. So V1 upon V2 is going to be of the same ratio as X upon L minus X, which is this. Again a simple question, but requires you to understand the logic that the voltage is directly proportional to the length, because if this if x increases, let me just erase this. Let's say if the sliding contact is brought over here instead of over here, which means that x is increasing, so even v1 is increasing, so v1 is directly proportional to x and v2 is directly proportional to L minus x, so v1 upon v2 is equal to x upon L minus x. So 37 answer is going to be D. Alright, yeah. So moving on, the first artificial radioactive substance was bombarding aluminium 2713 Al with alpha particles. This produced an unstable isotope of phosphorus 350. Okay, what was the byproduct of this reaction? So we just have to find the difference. So difference between these two compounds. So 2713 Al to phosphorus 3015. So well, and this was bombarded with alpha particles. So aluminium was one of the alpha particles. So plus 42. So if you see, if you balance the numbers, this should the left hand side, the mass number is coming to 31, so there should be some particle with mass number 1 and this, the proton number is 15, so number of protons is 15 balanced, so 1 0. Which particle do you think has mass number of 1 and proton number 0? Alpha particle has 4 2, so definitely not alpha particle. Beta particle has negative charge, but in over here there is no charge, again no. Gamma particle is something like this, so again not a gamma particle. Only a neutron has, well, mass 1 and no charge, 1 0 n. Alright, so this is going to be a neutron. Uranium 238 decays by alpha emission into a daughter product, which in turn decays into a beta by beta emission into a granddaughter product. What is a granddaughter product? So 238 uranium 92 first decays by alpha emission, so forms 234 and 90 plus alpha 42. Alright, then from 234 90 to decays by beta emission, so by beta emission it's going to give us, okay, I'm just using U, which is wrong. It's going to be some, it's going to form some element, and beta emission means mass number remains the same, and since we only have beta negative emission in our syllabus, which means proton number increases by 1, so 23491 no, yes. Alright, so first we form this alpha equation where it decays by an alpha particle and then by a beta particle, a beta negative particle to be precise. Which statement of a nuclei is correct? So different isotopic nuclei have the same proton, have different proton numbers. Wrong. Isotopes have different mass number, they have the same atomic number but different mass number, which due to difference in different neutron number. For some nucleon number can be less than the proton number. Definitely not, because nucleon number actually includes proton number. It's proton plus neutron, so definitely not. Some nuclear processes, mass energy is not conserved. Mass energy is always conserved. Always. Mass energy is conserved along with momentum and spin pair. Nuclear numbers of nuclei unchanged by emission of beta particles. That's correct. We can just use the reference from the last. We can just refer from the last question. During the beta emission, 234 x 90 got converted to 234 Ta 91. Only the proton number changed, but the mass number remained the same, 234 and 234. That's why D is the correct answer. Well, seems like we're on the last question. Hope you guys enjoyed my solving, and I know my the way I solve is a bit boring, but I'm learning and learning. Well, this was my first MCQ paper. So guys, thanks for watching and keep watching GCSE Paradox. Signing off.